Alright. This is the Lab 6 update. My name's Alex Dean, and today I will be showing you what I am doing for the last lab in this class. What I am planning on doing is creating a pathfinding algorithm using the A-star, because I'm an A-star, just kidding, A-star algorithm, and very basic. I'll show you what it does first, at least what I have that it does right now. Oh, you can't see anything in game, but if you go to scene, you have Gizmo's drawings. And I'm doing this as of now for testing purposes to make sure everything works as of now. And as we see, I created a test that works. It creates this grid, which is a 10 by 10 with cell size of 1. And we have found a path of 9 nodes. So path found with 9 nodes. So I'll get into what that means in a moment. First, I will show you this Pathfinder system, which holds my grid manager and my pathfinding script, both very important. And then my grid manager, which has, both of them are mono behavior, has 3 settings: grid width, height, and cell size. So let's get into it. Node, basically just an object that holds what my nodes are. We have our G cost, H cost, and F cost, all 3 very well used throughout my code. Cost from the start, our heuristic cost to target, or estimated, and then our total cost. Grid manager, very basic grid manager. Just creates the grid using our node parameters, which are in here as well. We have whether or not a path is walkable, the position, and its X and Y grid position. And yeah, that's how what we use to create our grid. I mean, yeah, there's not much I have to explain here. Basically just, yeah, return node to corresponding world position, you know. Not much that you don't know here. And this is my Gizmos drawing. I'm going to get more into implementing in-game objects soon. And then over here we have our pathfinding algorithm using the grid manager. Again, using these grid components like my life depends on it, but that's why it's there. This is my test. I call it start. That way, that's what runs right away. It starts from 0, 0, 0. And it goes pretty much to the end with, if you think about it, cell size of 1, grid size of 10, 10, that makes sense, you know. With it being all the way at the end, it'd be ending at 9 since I went and made it to the grid size -1. Path isn't null, found the path, or there's no path found. That's all done with this algorithm here, which I'll just show that for a second. I don't really feel like I have to explain it. I mean, we learned most of this already. I did create some helper methods though. We have retrace path, find neighbors, which is in my grid manager right there, which is very helpful, and getting the distance. And the way how we get distance is a heuristic method using diagonal distance. So it's estimated, but from what I have found, it is pretty concise. And then retrace path, very helpful for when we reach the end node. Retrace path, very important when we want to get to the end, or when we get to the end node, we want to get back to our starting point. So, let me cut back to my scene here, and I'm going to explain to you what I want to get done. I didn't make a Google slide, but I can just explain it. I'm pretty descriptive. First off, I want to work on visualization. I want colors to show the path. I want colors to show my start and end node. So if I want to start here and I want to end over there, I want like green and red, and I want the best path to be highlighted in blue, something like that. And I want some more debugging tools to show the best path that I think will be the best course of action as well. That way it'll all be in the console, just popping up best fast found, or couldn't find a path, this, that, and the other. Next up, I want to add interactive UI and some obstacle placements. So obstacles, the thing I'm thinking is like if we have a start and end here, I want the user to be able to click to A, update the start position, and B, possibly place some obstacles. That way we can mess with the path. So let's say the path is a straight line, that's the best path. What if I add an obstacle here and here? Well, now it's going to have to find another way around that, or here, 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 and here. Now it's going to have to find another way around that. Just basic things like that. And then lastly is just going to be some integration, some testing, and polish everything up, and then it'll be the final demo. So I hope you enjoyed this update. Thank you for watching, and have a good rest of your day. See you!